Hi, welcome to the second module of our Cloud Practitioner Study Series. And this module is focused on the cloud concepts domain, and we're going to talk about what exactly is cloud computing. So strap in and let's go. So what is cloud computing? First, I'm going to start with my definition. And this is somewhat simplified to what we're going to see from AWS. But to me, cloud computing is the ability to rent IT resources such as servers, databases, and networks and storage over the internet. And in cloud computing, you only pay for what you use. Now let's look at what Amazon, and specifically AWS, and how they define cloud computing. For them, they say cloud computing is the on-demand delivery of IT resources. So on-demand means, in contrast to on-prem or traditional computing, and we're going to talk about that in more detail, that you can have these resources when you need it. So they're instantaneously or almost instantaneously available to you when you need it. And you get those over the internet with a pay-as-you-go pricing methodology. And pay-as-you-go means you only pay for what you use. Again, that's in contrast to traditional computing where you buy your hardware and whether you use it or not. Just like when you buy a car, you can drive it all you want or you can leave it in your garage, but you're still paying for it either way. And the same with traditional computing. You're going to pay for those servers, whether they sit there idle in a closet or if they're actually performing useful work. And then it goes on to say, instead of buying, owning, and maintaining physical data centers and servers, you can access these services on an as-needed basis. So again, as you need it. They're trying to get this flexibility idea across that when you need the services, great, you can go ahead and use them and pay for them. And so basically, those are a little more verbose way of saying that it is really renting. You're basically renting. Now, that doesn't sound very technical when you say I'm renting hardware and I'm renting data center technologies, but basically you are renting it. And it says here from a cloud provider like Amazon Web Services. So let's look at another definition, and this time we're going to look at what NIST, and NIST is just an abbreviation and an acronym for National Institute of Standards and Technology. So let's take a look at what NIST says about cloud computing. Well, first, on-demand self-service, very similar to how AWS describes it. Broad network access, basically meaning it's available across the internet, and the internet is broadly available to most users. Rapid elasticity means you can rapidly increase the amount of servers or resources, storage, network bandwidth, and you can also rapidly reduce the amount of resource you have. So and that's going to come up later in a future module, our next module, when we talk about benefits of the cloud. And NIST also mentions resource pooling, and that's something that a lot of users, when they use the cloud, aren't thinking about. But the bottom line is that your workloads, since they're virtualized, may be running on the same physical hardware, the same physical server that other customers are using. And if you have security needs or compliance requirements that require you to run your EC2, your virtual servers on dedicated hardware that no one else is executing on, then you can do that. Obviously, it costs a little more money, but the reason that they are as cheap as they are is because you are leveraging that hardware along others, and there's economies of scale at play there. Lastly, it's a measured service. So once you start using AWS, you'll notice that you are billed for most services by the hour. Things like Lambda are not measured by hour, but storage, EC2, a lot of the other services, you're going to get a bill and it's going to calculate how many hours you've used that service. Now let's talk about what computing was like before the cloud, and how do we refer to that? Well, most times you're going to see a reference to on-premises. And on-premises computing just means that the infrastructure runs on the property of a company, such as their own data center. Smaller companies don't have data centers, but they may have a server room. Or you might rent some space at a co-location facility, so you're putting the hardware, the servers, the storage, the networking gear that you own into a co-location facility. In that case, you still own all the hardware. You're just saying you don't want the expense or management of a data center, so you're letting someone else host that hardware for you. Not everyone says on-premises. You often see on-prem as an abbreviation, but it's the same as on-premises. And this is just kind of a pet peeve of mine, but if you say on-premise, premise is a different word than on-premises. So try to say on-prem or on-premises just to be grammatically correct. Now let's talk about traditional on-premises computing. So you have a company office or locations where users need to access your systems. You've got an on-premises data center, and that's where you're going to find the networking, storage, servers, software, everything that your end customers need to access your systems. Now, all of this hardware needs to be purchased, managed, and maintained by the company's IT department. And typically every 5 years, some companies maybe get 7 years or more out of their hardware, but at some point it's going to reach end of life or end of support from the manufacturer, and you're going to need to replace with new hardware. So the disadvantages of this approach and what the cloud tries to solve for companies is it obviously requires staff to implement and maintain the hardware. And this is what AWS defines as undifferentiated heavy lifting. So all the management of your operations, of your hardware, of the data center, that really doesn't contribute to differentiating your business, your company. Another disadvantage is it does require large capital expenditures. So every 5 years or 7 years or longer, you're going to have a large, sometimes multi-million-dollar investment every time. And acquiring new hardware takes time. You're not talking about hours. You're not talking about days. Often this is weeks or possibly months, depending on the supply chain issues going on and if there's anything like chip shortages that might affect you getting new servers. And it's also difficult to predict how much hardware you need. If your hardware is going to last 5 to 7 years, you have to try to predict at the end of those 5 or 7 years how much capacity do you need. And so there's a fine line between buying too much or excess resources and too little. You typically err on the side of caution. You never want to buy too little, but again, it's a balancing act. So in contrast, let's look at cloud computing. And in cloud computing, all of those components that ran in your own data center or in your own server closet are now moved into the cloud provider's data center. And so you are connecting from your locations, such as your headquarters or your offices, into the cloud provider's environment. And so the cloud provider maintains this infrastructure for you. You are simply renting access to the hardware. So let's compare and contrast on-prem versus cloud computing. From a hardware purchasing perspective, when you're on-prem, you're going to buy it. And in the cloud, you're renting it. And you're renting it on a, boy, if I'm using it, I expect to be billed for it, but if I stop using it, then I should not be billed anything. Who is responsible for the infrastructure? On-prem, obviously you or your company. And in the cloud, whether it's AWS or another provider, they're responsible for the compute infrastructure. In terms of capacity, the capacity is fixed. It's fixed at whatever you bought at that point in time. And if you need more capacity, you can fix that, but it's going to require additional purchases. In the cloud, it's virtually unlimited. Now, they don't have an infinite amount of compute resources, but typically they are going to have enough resources to satisfy even the largest company's needs. And lastly, the time required to provision new servers, or you could extrapolate this against any new resources. In weeks, if you're lucky. On-prem, it might be months, depending on, like I said, logistics issues. And then in the cloud, typically minutes, whether you're writing a script or doing something via the cloud portal. It only takes minutes then to provision new resources. And so this is why a lot of people are moving and migrating to the cloud. But like I said, we're going to get into more detailed analysis of the benefits in our next module. Let's talk about the 3 cloud as a service models that are represented here. First, infrastructure as a service, or IaaS, IaaS, and we're going to talk about these in detail on the following slides. There is platform as a service, or PaaS, PaaS. And lastly, software as a service, or SaaS, or SaaS. So let's talk about IaaS. For IaaS, you're running your networking, your storage, your servers, virtualization. All that is managed by the cloud provider. And then what are you responsible for? You are responsible for operating systems, maintaining those operating systems, patching those when need be, troubleshooting when they go down. You're responsible for the data and for your applications. And this is IaaS, and it's here managed by you. So your applications, data, and operating systems are managed by you. And this is commonly used when companies first move to the cloud. They perform what we call a lift and shift. And when they move to the cloud, they are lifting and shifting their environments, and you become responsible for the operating systems, data, and applications as illustrated here. In contrast to this, platform as a service is a little bit different. So with platform as a service, operating systems then are managed by the cloud provider. That frees you up from having to patch the operating system. So you're only focusing on data and applications. So simplifying the amount of things that you need to focus on. And some people would argue you're focusing what's most important to your end users, which is the applications and the data, and not the underlying infrastructure. Examples of platform as a service are managed databases for AWS, that's Relational Database Services, or RDS. Managed Kubernetes and serverless computing are all examples of how you don't have to worry about the underlying technology. And lastly, let's talk about software as a service. And in this environment, the responsibility for applications and data falls to the cloud provider. And the only thing you're worried about is renting the application. So you're not even worried about the software or the data. And examples of SaaS are Salesforce, Dropbox, Slack, Google Mail. So you are renting access to those applications. Now let's talk about the 3 cloud deployment models. You've got hybrid cloud, you've got public cloud, and you've got private cloud. And we're going to talk about each of these individually. For private cloud, everything is running in the company data center. So networking all the way up through the application software is running somewhere that you are either owning yourself, like your own data center or a server area, server closet, server room, or you're putting that in a co-location facility. But everything runs within this data center. And back in the day, this wasn't called cloud. This was just typical traditional computing, but we refer to that as private cloud now. Now let's look at what happens when you move to public cloud computing. For AWS, Azure, Google's compute platform, or any other cloud environments, All the networking up through the application software are running in the cloud provider's data center. So no magic here, no mysterious black boxes that do a lot of magical computing. It's still a data center under the covers. You're just renting it via the internet. And as it shows here, everything runs within the cloud provider's data centers. And then hybrid is kind of a blend of both worlds. So you still have your company data center running your application and your hardware stacks. You've got your cloud provider and you've got your application and environmental resources there. And then you're connecting both across data centers. And I work with a lot of AWS customers, and this is most common. There are always going to be some systems that at least larger companies, non-startups, but well-established companies, you're always going to run some things on-prem, maybe due to latency issues, maybe due to security concerns, etc. And then when you have the need for applications, companies have the choice. Is this something that is best put in our own data centers, a little closer physically to our environments, or is this something best suited for the cloud? And this is called hybrid cloud computing. So thank you for watching this module as we continue down our journey of studying for the cloud practitioner exam and certification. I'm going to show some recommended videos here as well as a link to the next module. But thanks so much for joining us. I appreciate your time and attention. Have a great day or great evening, great morning, and we will see you soon.